What if one of the biggest roadblocks in artificial intelligence wasn't some super complex problem with an algorithm, but a simple, deeply held assumption that almost everyone just overlooked? Today, we're going to dive into a story about a hidden barrier in AI that was just shattered by a surprisingly simple idea.
We've all seen it, right? AIs that can write poetry, whip up incredible images, even code a website from scratch. But here's the thing. There's a really strange paradox at the heart of AI development. For all that amazing brain power, we still have a really hard time teaching an AI something a toddler figures out instinctively: how to walk. So what's going on there?
Well, it turns out AI progress is happening at two totally different speeds. On one side, you've got your language and vision AIs, and they are just exploding with rapid, scalable breakthroughs. But on the other side, you have a field called reinforcement learning, or RL, and that's the trial and error kind of learning we desperately need for things like robots. And in that area, as a recent research paper puts it, progress has remained elusive. Kind of says it all, right?
To be more specific, we're talking about self-supervised reinforcement learning. Now, think of it this way. Instead of showing an AI a million videos of how to walk, you basically drop it into a virtual playground and just let it figure things out for itself. It has to explore, it has to set its own goals, and it learns from trial and error. All of this without a human there patting it on the back and saying, "Good job." This is absolutely key if we ever want to create truly independent machines.
So, what was the holdup? Why was this super crucial area of AI stuck in the slow lane? Well, the answer, it turns out, was hiding in plain sight. It was an unspoken rule, a piece of conventional wisdom that was quietly holding the entire field back.
For years, the standard blueprint for building these learning AIs used what are called neural networks. You could think of these as the artificial brains of the system. The layers in these networks are kind of like levels of thought. The more layers you have, the more complex the ideas the AI can put together. And the unwritten rule, the community standard, was to keep these brains very, very shallow.
And just how shallow are we talking? Just 2 to 5 layers. That's it. To give you some perspective, the large language models we use every day can have hundreds of layers. So why was the standard for learning robots so tiny? This was just the accepted best practice, the status quo that pretty much everyone followed. But then, a team of researchers decided to challenge this fundamental assumption. They took a long, hard look at this unspoken rule and asked a really simple question. What happens if we just break it?
The researchers started wondering, hey, maybe the problem isn't that our learning algorithms are wrong. What if we've just been giving them brains that are way too simple to learn these complex tasks? What if the key wasn't some fancier, more complicated algorithm, but simply more depth? So they didn't just add a few more layers. They took a truly radical leap. They went from that industry standard of 2 to 5 layers all the way up to 1,024. I mean, this was not a small tweak. This was a completely different philosophy. And the results of this one simple change, they were, to put it mildly, astonishing. This wild experiment in depth led to some absolutely incredible and honestly surprising breakthroughs in the AI's performance.
On every single task they tested, from simulated walking to moving objects around, the deep network absolutely blew the shallow ones out of the water. And we're talking about a performance increase of between 2 and 50 times. That's not an incremental improvement, that's a giant leap forward.
But here's where it gets really, really interesting. This wasn't just about the AI getting better scores on the same old tests. The numbers were only half the story. Something much more profound was happening inside that deeper network.
The researchers put it perfectly in their paper. They said that increasing the depth didn't just improve success rates, it qualitatively changes the behaviors learned. So, in plain English, the smarter AI wasn't just doing the old tasks better, it was discovering entirely new, more complex ways to solve problems all on its own.
So, this is fascinating research for sure, but what does it actually mean for us? Let's break down what this kind of breakthrough really unlocks for the future of AI and robotics.
It really creates this clear path from theory to reality. So first, these deeper networks give the AI a much richer ability to understand its environment, and that lets it explore more effectively. This better exploration then leads directly to the AI learning more complex behaviors from scratch, like how to get around and manipulate objects. And that capability right there is a critical stepping stone towards the kind of autonomous general-purpose robots we've been imagining for decades.
Okay, so what are the big takeaways here? 1. Depth isn't just a minor detail, it is a critical factor for scaling up this kind of AI. 2. Going deep unlocks entirely new abilities, which allows an AI to set and achieve its own goals. This means we can now train AIs on complex physical tasks without any human guidance, and that just paves the way for a new generation of smarter, more autonomous robots.
And all of this leaves us with one final fascinating question to think about. For years, progress in this vital field was being held back by a simple, unexamined belief about network depth. Now that we know better, it really forces us to ask, if a change this simple caused such a massive leap, what other basic assumptions are we making right now that might be holding back the next great breakthrough in AI?